Welcome in our session for today, of which we are going to take differentiation as well. We are going to take calculus starting from differentiation, since you know that calculus entails both differential and integration. So in this session for today, we are going to do our introduction with differentiation using the first principle formula. Since you know that when we have a number like, for example, you can have a number like 2x squared. In a normal differential, we can differentiate this so as to have 2 into 2x 2 minus 1. To mean that you take whatever you have on the power, multiply with it whatever is within the bracket, and then from the power you subtract 1. When you work out this one, you're going to have 4x power 1 as your answer. So the way we've done this one, this is just a normal differential. But we are going to take this one using now the first principle formula. And by the first principle formula, we need to understand that a function, this one is a function, the given function f of x is equals to limit h approaching 0h, or in some books it is denoted as, the formula is written as limit h approaching 0 of a function f of x plus delta x minus the function f of x all over delta x. So this is the notation of delta x. But I'm going to use this one because at least this one has got a difference as compared to the other one. This one is cheaper to understand, but if you understand both of them, it is well and good. So you can be given this one. You can be given a function f of x, a function f of x is equals to 2x squared. And then you are being told to use the first principle formula in carrying out the differential of this one. So let us come to the formula whereby we understand that the derivative of a function f of x is equals to limit. What you need to understand here is that where we have x squared is where we are going to replace with f plus h. And then the function f of x is what we have here. So let us come and do this one whereby we are going to have limits h approaching 0. The function f of x, we are going to have now f, the function x plus h will be now 2 into, we'll say that where we have x, we replace with x plus h, because it was 2x. Rather than writing 2x, and we are going to use the first principle formula where we have this x squared is where we are, this x is where we replace by writing x plus h, but everything was squared minus this function. The whole function is 2x squared all over h. After reaching here, now let us work out the bracket. Let us open the bracket to make everything simple. And here we are going to have limit h approaching 0 will be equals to, here we are going to have 2 into x squared, everything all over all over h. Let us now open the bracket. Sorry for this. We are going to have limit h approaching 0 will be 2. This one times this one we are going to have 2x squared. This one times this one we are going to h. When we come here, when you look at the numerator, we have common factors, and the common factor will be 2x squared minus 2x squared, of which they will cancel out, and we will be having limit h approaching 0. This one is of a function f of x will be 4x h plus 2h squared all over h. And from here now we can do away with h. Since we have h here and we have h here as a common factor on the numerator, it can cancel h on the denominator. Function f of x is equals to limit h approaching 0 equals to 0, whereby we are going to this one and this one will cancel out. Limit h equals to or approaching 0 will be equals to 4x plus 2h. And in our last step, we are going now to take, because we have limit of h equals to 0, where we have h in the equation is where we are going to replace with h. And now in our final level, we are going to have x plus, since we don't have a term of h here, we leave it the way it is, plus, here we are going to have 2 into 0, because we say that the limit is h approaching 0. And when we work out this, then we are going to have 4x as our answer. And now let us come and check what we did on our normal differential. You will find that this one and this one are equal, and that is our answer. So this is the doing differential, carrying out differential using the first principle. Using the first principle formula, find the derivative of this function. And by that, what you need to understand is that you need to understand the first principle formula. The first principle formula, as you said, goes by the derivative of a function f of x is equals to limits all over h. Now, let us dive down into the equation. We say that in the equation, whenever we have x, that is where we are going to replace with x plus h. That is now our first step. Just come to the equation and identify where we have x and insert, replace with x plus h, whereby we are going to have limit 5, where we have x, you replace with x plus h plus 2 minus the function, the whole of this function, the function given. This is our first bracket. 5x plus 2. Everything will be now all over h. Let us now work out what we have within the bracket. we are going to have limit h approaching 0 is 5 is equals to, here we are going to have 5x. This one will, everything will be all over h. Let us simplify what we have on the numerator. We have limit h approaching 0, whereby now we'll be having 5x, and by simplification of what we have on the numerator, we collect the like terms together. 5x minus 5x, here we'll be having plus 5h, and lastly we are going to have plus 2 minus 2. So this one will cancel out, this one will cancel out, and here everything will be on over h, and lastly we will have limit all over h. H and h will cancel out, h approaching 0. And in this step, when you check out what we have here, we have 5, only 5. We don't have a term of h, making our answer to be 5 in the long run. Since we don't have a term of h, unlike the other one, we have a term of h here, whereby we are replacing h with 0. And now, let us come to the normal differential of this. The normal differential of that we are going to have, when we differentiate this one, we will be having 5x plus 2. When we differentiate this, we will be having 5, and when we differentiate that, we will be having 0, making our answer to be 5. So this is just the carrying out differential using the first principle. Let us now get into our next example. This is now our example 3. And in our example 3 formula. And the formula goes by the derivative of a function of x is equals to h. After understanding the formula, we say that in our second step, we are going to have, in our second step, what we are going to do is that whenever we have x, we replace with x plus h. To mean that in this function, here we are going to have a replacement of x plus h after writing 3, and here we are going to have minus 7x plus h, and here lastly we are going to have 2. Since it doesn't have a term of x, we are going to leave it at that point, and then we do that, and then we replace with the function f of x given in the equation all over x. So here we are going to have limit h approaching 0. The whole of this one will be 3. Now we jump into here, x plus h. Everything is squared because this is where now we have the term of x. This one will be minus 7 into x plus h, and lastly we are going to have plus 2. Now let us jump into the functional side, where we are going to have now we are going now to have 3x squared minus 7x plus 2. Everything will be 1 over h. Let us now simplify what we have within the bracket first, whereby we will be opening this bracket, limit h approaching 0, h. Let us simplify what we have within this. We have within this bracket, we are going to have limit h approaching 0 will be 3. Everything now will be 1 over h. Now let us try to collect the like terms together. Limit h approaching 0. Here we are going to have 3x squared minus 3x squared minus 6xh, and we don't have a term of 6hx plus 3h squared minus 7x, and here we have plus 7x minus 7h, and here lastly we are going to have plus 2 minus 2. Everything will be all over h. And now after collection of like terms together, this one will cancel out, this one will cancel out, and lastly this one will cancel out. And in these steps, in our last steps, we are going to have limit h approaching 0 will be equals to 3h squared minus 6xh, and lastly we are going to have minus 7h. Everything will be 1 over h. When you check on the numerator, from here, we have a common term of h here, and h here. To mean we are going now to have limit h approaching 0, h into, on the numerator we are going to have 3h because it is squared minus 6x minus 7. Everything on over h. Let us now do away with the term of h. This one will cancel out with that, and we are going to have limit h approaching 0 will be 3h minus 6x minus 7. At this step, we say that whenever we have h on the equation, we replace with 0. And now we are going to have 3 into 0 minus 6x. This one doesn't have a term of h, and this one will be minus 7. Sorry, here there was a sign that I changed. Sorry for that. There was a sign that I left here. And lastly, when we are work out what we have here, we are going to have this one will be 0, 6x minus 7 as our answer. Now, for us to prove that this is the answer, let us come to the function, the one that was given earlier, and check what if we do a normal differential. In a normal differential, we are going to have this one as 2 into 3x 2 minus 1 subtract from 7x raised to power 0 plus 0. And when you account this one, you are going to have 6x minus 7. And the two matches the other, the two answers. To mean that that is the correct answer when you've been asked to carry out your differential using the first principle. Let us now get to our last example. Now, in our last example, which is example 4, we have a function f of x is equals to 3x power 4 minus 2x squared and 2x minus 3. First thing that you need to understand about is the formula. And the formula using the first principle is the differential of a function f of x all over h. We say that in our first step, whenever we have x in the equation, we replace with x plus h. And that is what we are going to do in our first step, whereby now we are going to have a function f of x, limit h approaching equals to or approaching 0, 3 into, we are going to have x minus 2 into x plus h squared. We add to 5 into x plus h, subtract from 2. Now let us jump to the other side of a function of x, and the function of x is what we have here. We've been given 3. This one is on its own bracket. 3x power 4 minus 2x squared at 2, 5x subtract from 2. Everything is. Let us open what we have. Let us simplify what we have within these brackets by opening the brackets, and we'll be having limit h approaching equals to or approaching 0 into 3 into, here we are going to use the Pascal's triangle, whereby x power 4 h power 0, one power increases while the other one decreases. The first term, its power increases while the other one decreases, at 2x h, without inserting the coefficient first to avoid confusion. And here we are going to have x squared that this one is correct. We've only opened this bracket. Let us now get into this one. Subtract from 2 into, when we open this one, we will have 2 squared. We've already opened that bracket. Now let us get into this one. We will have 5x, 5 into x plus h. We will simplify what we have within this bracket. This one will be minus 2. Now we are done with our simplification of what we have within the brackets. And now let us get to the term of the to the side of the function of x. The everything will be all over h. Let us now insert the coefficients here and open the brackets. Limit h approaching equals to or approaching 0 will be equals to 3 into, here we are going to have, here the coefficient will be 1, here the coefficient will be 4, and these other ones, here when we open the bracket here we are going to have minus 2x squared, here will be minus 4x h, and here we are going to have a negative of 2h squared. Lastly, we are going to have plus 5x plus 5h subtract from 2. When we open the bracket on the other side, we are going to have minus 3 addition of 2. And everything will be all over a term of h. Let us now open what we have within this first bracket. We are going to have limit h approaching 0 will be 3x power 4. We add to 12 x cubed h and subtract from 2x squared you subtract from minus add to 5x subtract from 2 power 4 subtract from 2x squared subtract from 5 add to 2. Everything is over a term of h. In our next step, we are going to have limit h approaching 0. Let us now collect the like terms together by having 3. In this step now, we are going to collect the like terms together. X power 4. Any term of x power 4 we have here. Subtract from 3. X to power 4. Add to 12x cubed. And here 18x squared h squared to x squared After now collection of like terms, now we come and check these two will cancel out. These terms will cancel out. These terms will cancel out and these terms. Those are the terms that are going to cancel out since they were like terms. And we are going to be left with limit h approaching 0 x cubed h add to 18x squared h squared. We add to 12x all over h. When you check on the numerator, each and every term has h, has a term of h. To mean we can collect h as a factor on the numerator. And we are going to have a function limit h approaching 0. We are going to have h as the common term of the numerator being factored out 12 h. After factoring out h on the numerator, it will help us in cancelling h on the denominator before we insert h in the terms that is required. And here we'll be having this one cancelling this, we'll be having limit h equals to or approaching 0 will be 12x cubed add to 18x squared h. We add to 12x squared 3h cubed minus 4x minus 2h add to 5. Since we say that the limit is h approaching 0 or equals to 0, where we have a term of h on the equation we replace with 0. And now we are going to have 2x cubed plus 18 x squared into 0 plus 12x into 0 squared plus 3 into 0 cubed minus 4x plus 2h plus 5. All the terms of h will cancel out. This one, if you multiply by 0, will cancel out. This one will cancel out. This one will cancel out. And this one will cancel out. And now we will be left with 12x cubed minus 4x. We add to 5 as the differential of this function using the first principle. Now let us do our normal differentiation. Without using the first principle to confirm our answer, we are going to have, when we differentiate this one, we'll be having 12x cubed. When we have a differential of this, we'll be having subtraction 4x. And lastly, we are going to have an addition of 5 here. And the this one is confirmed to be the correct answer. So this is how you go about differential using first principle on different questions if you've been asked. Otherwise, thank you for your time.